For the amount of concepts discussed, let us start doing some problems. One problem that they have given in your textbook is two identical spheres of mass m. They are equally charged. They are suspended by means of strings of length L. When they are in equilibrium, that means when they are not moving at all, each of the sphere makes an angle theta with the vertical. Then find the charge on each of the spheres. That means here you are asked to find the charge of the sphere Q. Let us assume that each sphere has charge Q. The given are L, M and theta. Your answers must be in terms of L, M, theta and maybe the electrostatic constants and gravitational constants. Because mass is given, there will be gravitational force and there is repulsive force also. We are going to take into account. So the thing is, here it is at rest. When you look at this mass, it is at rest because there is one force acting on this mass which is called tension. This makes an angle theta with the vertical, and there is electrostatic repulsive force between these two, and that is electrostatic force Fe, because these two are like charges, they are going to repel each other. And the third force is M is the mass, the downward force will be mg. Under the action of these three forces, it is at rest. Because it is at rest, mg has to be balanced by some other force and Fe has to be balanced by some other force, because the T is here, has this component T cos theta, T has the other component T sin theta. These are rectangular components, we had seen enough in the last year. This T cos theta is balancing mg, T sin theta is balancing Fe. If you write the equation, I intend to solve this problem in at least three methods. Let us try to solve in the first method. Here, method 1. Here it is, T sin theta is balanced by Fe and T cos theta is balancing mg. When you divide these two, tan theta equal to Fe by mg. When you cross multiply mg, tan theta is what we are getting. Let me see if we can arrive at the same result using some other method. In the last year we had studied that under the action of three concurrent forces, if an object is at rest, we can write force 1 by the sine of opposite angle will be equal to force 2 by sine of opposite angle and force 3 by sine of opposite angle. In the same fashion, here this is the mass m and this force is tension T and this is electrostatic force Fe. This is the gravitational force mg. And this makes an angle theta with the vertical. If this is theta, this total angle will be 90 plus theta. This angle will be 180 minus theta and this angle will be 90 degree. Then tension 1 by opposite angle can be written as T by sine 90 is equal to mg by sine of 90 plus theta, mg by sine of 90 plus theta, which will be equal to Fe by the opposite angle or sine of 180 minus theta. So it is Fe by sine of 180 minus theta. If you consider these two things, Fe by sine of 180 minus theta is sine theta, mg by sine of 90 plus theta is cos theta. When the sine theta goes up, sine theta by cos theta is tan theta, mg tan theta. So electrostatic force will be equal to mg tan theta. We have arrived at the same result using our method 2 also, method of concurrent forces or Lambda theorem. Let's look at the third method. Here what principle we have applied is the net force acting on the system is 0. That means there is no translational motion. And here, because the system is in equilibrium, it is at rest, the net torque acting on the system is also 0. So sum of the torques must be equal to 0. Here sum of the force is 0, here sum of the torque 0, hence there is no rotational motion. So in our method 3, we are going to use this. What happens here is, this electrostatic force try to make the system move this way, but the gravitational force try to make the system move this way. And let us have this diagram very clearly. Then this sphere and the other sphere is here, and this length is L, this angle is theta, then this distance is L sine theta, and this distance is again one more L sine theta. I hope you know the distance between the spheres, we can't simply write R here. Because of this, it is L sine theta and it is L sine theta, totally 2L sine theta. Okay, here what happens, this electrostatic force, try to take the system this way, then electrostatic force. What is torque this way? The torque this way is force into perpendicular distance. Here about this point of suspension only it is trying to rotate. So about this point of suspension, the torque is force into perpendicular distance to the force from the point of suspension. So there are two distances to the point of suspension. One is L sine theta and this one is L cos theta. So which is perpendicular to this force? Fe L cos theta. Then torque this way is equal to Fe into L cos theta, which is balanced by torque produced by mg, which is trying to take the system this way, and mg from the point of suspension the perpendicular distance is L sine theta. So F is equal to Fe into L cos theta must be equal to mg into L sine theta. L and L will be cancelled. Fe will be equal to mg into sine theta by cos theta is tan theta. In all three of our methods, Fe yields mg tan theta. So what we have arrived at, Fe is equal to mg tan theta. So m is in our answer charge. Everything is going to be in terms of theta, m and other things. What is electrostatic repulsion between these two charges? This is Q, this is Q. Same charge Q. Q is the unknown. So one of the force K into Q1, Q2 by R square, the distance between them square. This is a right angle triangle. This is L. Then the opposite side to theta is L cos theta. This is going to be 1 L cos theta. So it is going to be 2L cos theta. So R is equal to 2L cos theta the whole square, which is equal to mg tan theta. Hence Q into Q square is equal to 2L cos theta whole square into mg tan theta by K. K is electrostatic constant, value is 9 into 10 power 9. So in order to find Q, you have to take square root on both sides. So Q becomes 2L cos theta into root of mg tan theta by K.